Hi my clients, welcome back to my YouTube channel Maths for my clients by MKV. So dear students, before starting today's class, I want to tell you, please don't forget to give your attendance on your this YouTube comment section. Second thing, regarding your practicals, I told you arrange the practical file and the colored papers, etc. So for that, if you are not able to arrange any practical file, you can do the practical in your register, and if you are not able to arrange any colored paper, you can use the white paper, and that I will tell you at the time of explaining whenever I will use colored paper for the practical. But for today's practical, I require only graph papers. So if you have graph, please draw the diagram on the graph papers, right? And third thing is, today in the evening I'll send you online test at 4 o'clock. So you have to complete, you have to fill all the answers, and I'm giving the time from 4 to 6. Within 2 hours you have to fill the form and submit it to me, right? So this will be online test. So I hope you understood, and if there is any problem, you can send me through WhatsApp. So be ready for the today's class. Today I am going to tell you the activity number 1 to do in practical file. If you are not having practical file, you can do it in your register. Now over to screen. Okay, so children, in today's class, for doing the activity, you need to write these steps. So what are the steps? In your practical file, you will write first step, objective. So first of all, you will write heading or objective, and then you will write its objective of the activity. Second thing is, what are the material required to do the activity? So those things which are required to do this practical activity, you will write these things in neat and clean writing, either in your register or in your file, whichever is available with you. Third thing is theory. Theory means the principle, on the base of which principle, which theory it is based on this. So you will write that theory. And the procedure. Procedure you will write in your own words. If it is long, you can write it in short, but use your own words for the procedure. Next is fifth step, that is observation. So you will observe what you are observing in the questions, and that observation you will arrange in the table and write it. And the last step will be conclusion. So in the end, you will write what is the conclusion of the activity, right? So you note these points, and please follow this at the time of writing the practical in your notebook, right? So now see the activity number 1. First step was activity, this objective. So you will write the objective. What is our objective of today's activity is to use the graphical method. So we will use the graphical method to obtain the conditions of consistency. So we will get the conditions of consistency. Consistency means when they have the solutions, and has to solve the given system of linear equations in 2 variables. So we will take a system of 2 equations of 2 variables, right? So we will get 2 equations, and then we will try to get some conditions. So about this I have already taught you when I taught you the linear equation chapter, but once again we will do this practically. So now second step is material required. So for this, 3 sheets of graph paper required. Next is 1 ruler is required. Third one is 1 pencil is required. So pencil, ruler, and 3 sheets of graph paper, right? So these are the things, you will write this in your notebook. Third step is theory. So in this you will write the theory. The lines corresponding to each of the equation given in the system of linear equations are drawn on a graph paper now. So we will draw the lines on the graph paper, and after that we will prove these following conditions. Number 1, if the 2 lines intersect at a point, then the system is consistent and has a unique solution. So we will plot a graph, and then we will see that whether these lines are intersecting or not. So if these lines will intersect, we will say if the system is consistent, and we will say it has unique solution. Unique means one solution. Second condition is if 2 lines are coincident. So if 2 lines will overlap each other or coincident, then the system is consistent, it has solution. Consistent means it has solution and has infinitely many solutions, right? So this is the second condition. Third condition is If two lines are parallel to each other, then the system is called inconsistent and we will say it has no solutions. So these are the three conditions. So practically we are doing, and we will do it theoretically also. I have already done, but I will revise when I will start this chapter again at the time of revision. So that time also you can understand. This I have already taught you, and we are doing this, its proof today practically. Right? So I hope you understood all these 3 points. First is objective, second is material required, third one is theory. So these all the things you will write in your notebook as it is. Right? Now, to do this is the procedure. We shall consider a pair of linear equations in two variables of the type. This is the standard form. a1x plus b1y is equal to c1, a2x plus b2y is equal to c2. This is the standard form of linear equation. So we will take first example. So first system of linear equation B. So I have taken the equation x plus 2y is equal to 3 and 4x plus 3y is equal to 2. So first of all, we have taken these two equations and we will plot the graph for these two equations, right? So to prove this, what will you do? This was your first equation. So from this equation we can find the value. So 2y is equal to 3 minus x, and then y is equal to 1 upon 2 into 3 minus x, right? So x you will transfer to the right side, so 3 minus x, and 2 will go down, so y is equal to 1 by 2, 3 minus x. After that you will make a table, and in this table here you will make 4 boxes. Here I made 3, 1, 2, 3, one more box you will make. So you will find out 3 solutions. I will tell you the reason why 3 boxes here, why we should find out third solution. So for that I have taken it from the book, so I made it 2 boxes here for the solution, but you will make 3. So first of all we will put the value of x. If I am putting x is equal to 1, so it will be 3 minus 1, that is 2, 2 cancel, so here we will get 1. So y is equal to 1. Now you will put x is equal to 3, so 3 minus 3 is 0, 0 into half will be 0, so y is equal to 0. So this is the second solution. Similarly, you can put this x is equal to minus 1, so it will be 3 minus 1, so that is 4, 4 upon 2, 2, so y is equal to 2. So x is equal to minus 1 and y is equal to 2. In this way you will get third solution, right? Similarly, this was the second equation. From this 4x you will transfer to the other side, so it will be 2 minus 4x, and then 3 will go down, so it will be 1 upon 3 into 2 minus 4x. This is the value of y. Now here you put x is equal to minus 1, so minus 1 into 4 will be minus 4, and 2 minus, so it will be plus 4, so 2 plus 4 6. 6 divided by 3, it will go 2 times, so y is equal to 2. Now you put x is equal to 2, so it will be 2 for the 8, so minus 8, so 2 minus 8 is minus 6 divided by 3, so it will be minus 2. Similarly, you can put one more value of x and you can get one more value of y, right? So you will prepare 2 tables of 3 solutions each, right? After this you will plot the graph for this pair of linear equations. So for this, these were the tables. This is the table for first equation. Similarly, this is the table for second equation. After this, we will plot these points on the graph. So this is the graph. In this graph, on this dark line, we will draw a line parallel to the ground. On this dark line, we will draw a line with the help of pencil, and after each centimeter at the cutting point, and one line is vertical, so both the lines are intersecting at this point. This point is called origin. Now from here, at each centimeter, you will write 1, 2, 3, 4, 5, right side positive, left side all negative. So minus 1, minus 2, minus 3, minus 4. Upside also each centimeter 1, 2, 3 positive, downside each centimeter 1, 2, 3 with negative sign. So this side we are taking all positive x, this side all negative x, upside all positive y, and downside all negative y. This is sign convention. After this we will plot 1 and 1. So x is equal to 1 and y is equal to 1. So this is the point 1, 1. After this we will find out 3 and 0. So x is equal to 3 and y is equal to 0. We are not going up. So this is the second point. This is the first point. This is the second point. You will find out third point. I told you third point you will find out. So third point, suppose that may come here or may come here, right? So if all 3 points are lying on the line, it means our calculation is correct. if third point which we are finding here, if that point is not lying on the line, so you can understand that there is some mistake. So that will help you in rectifying your mistake. Similarly, here you will find 3 points. So first point is -1 and 2. So x is equal to -1 and y is equal to 2 is this point. X is equal to 2 positive and y is equal to -2 is this. So 2 and -2 is this. So after plotting these points, you will join these 2 points and you will join these 2 points, right? But I told you 3, so 3 points here and 3 points here you will join. So you will get 2 straight lines, and after plotting this you are observing here that both the lines are cutting at this point -1 and 2. So we are observing lines are intersecting, and if they are intersecting at one point, so we will say lines are consistent, system is consistent, and it has unique solution. So this system has unique solution, one solution. Why one solution? Because both the lines are cutting at one point. So this is the diagram for unique solution, right? After this we will plot the graph for second condition. So for that we will take these two equations, x minus 2y is equal to 3 and minus 2x plus 4y is equal to minus 6. Now from this first equation you can find out the value of x. So x is equal to 3 minus 3 plus 2y, and put the value of y is equal to 0. So it will be 3, y is equal to -1, so x is equal to 1 from the first equation here. From this equation you can divide each term by 2 because all the numbers are divisible. After that we can put these values in place of x and we will get the corresponding values of y. So we will get two tables for these two equations. After writing three solutions for each equation, now we will try to plot the graph. So this was the first equation and these are the two solutions. I told you find 3 solutions, right, for the practical. Similarly here this is the equation and here 2 solutions, you can find out one more solution. After that you will plot the graph for this. So first point is 3 and 0. So x is equal to 3 and y is equal to 0 is this point. Then x is equal to 1 and y is equal to -1. This is the second point for the first line. You can draw a line by joining these 2 points. After this third point -3. So x is equal to -3 is there and y is equal to -3 is this. So -3 is this point. Next point is -1 and -2. -1 and -2. Join these 2 points and then draw a line. So you will observe the first line and the second line both will overlap. So one line is this, one line is this, both are in the straight line. So when you will extend, one line will overlap the other line, right? So both the lines are coinciding, overlapping lines, and whenever two lines will intersect, overlap each other, so each point of each line will touch each other and they will have infinitely many solutions. So this is the case of system consistent and have infinitely many solutions, because each point of this line and each point of this line both are overlapping, so each point will touch each other or intersect each other, so they are having infinitely many solutions. So this is the graph, this is the proof of this condition. Now come to the third condition. So for the third condition we are taking 2x minus 3y is equal to 5 and minus 4x plus 6y is equal to 3. These are the two equations we have taken. So from this first equation we will find out the value of x. X will be equal to here 5 plus 3y upon 2. So 5 plus 3y upon 2, and second equation we can write the value of x. X is equal to 3 minus 6y upon minus 4. Now in this equation you put the value of y. So y is equal to -1. So 3 into -1 it will be -3. So 5 minus 3 is 2. 2 divided by 2 is 1. So we got the first point. Then put y is equal to 1. So y is equal to 1. So 3 into 1 3. So 5 plus 3 8. 8 divided by 4 is 8 divided by 2 is 4. So 4 times. So we got this point. Similarly we can find one more point. Now similarly from the second equation, here you will put the value of y and you will get the value of x, or you can find out the value of x after transferring, find the value of y after transferring the term x. So here you will get two tables after simplifying, and after this you will plot the graph. So this is the table for the first equation, this is the table for the second equation. So plot the points 1 and -1. So x is equal to 1 and y is equal to -1 is this point. X is equal to 4 and y is equal to 1. So x is equal to 1 2, 3, 4 positive and 1 positive. So 1 positive. So 4 and 1. So this is a point 4 and 1. So x is 4 on x-axis and y parallel to y 1. So 4 and 1. So these are the 2 points. For the second equation, 0 and half. So x is equal to 0 is here and half is here for positive y. So this is the point 0 and half. Next is 3 and 5 by 2. 5 by 2 is 2.5. So 3 from here 1, 2, 3. X is equal to 3. Then y is equal to 2 and half. So 1, 2 and half 2.5. So 2.5 is here. So 3 and 5 by 2 means 2.5. So we got this point. So we got these 2 points here and here. These 2 points here and here. Join them. So after joining you will observe we are getting 2 lines and both the lines are parallel because gap here is same. So in this case 2 lines are not intersecting. So we will say this is the condition of no solution and we will say the lines are parallel. So in this way after plotting these graphs we are observing that the lines are parallel here. After this the next step comes, that is observation, and in the observation in the first case what you have done, you have drawn the diagram and you were observing there was one unique solution. So in that case you will find out the value of a1 upon a2, b1 upon b2, c1 upon c2. So a1 upon a2 will be 1 by 4, b1 upon b2 is equal to 2 by 3, c1 upon c2 is equal to 3 by 2. So from this you are observing this is not equal to this and this is not equal to this. So all three are unequal. So we are observing this relation that a1 upon a2 is not equal to b1 upon b2 is not equal to c1 upon c2. So these all three ratios are not equal to each other. So nature of this line is they are intersecting lines and they are cutting at one point. So the point of intersection of these two lines was unique solution and the point was -1 and 2. This is also known as the solution of two equations. So this is a observation for first case when the lines are intersecting at one point, and that was the case of unique solution. Now the second case, in the second case again you will find out the value of a1 upon a2, b1 upon b2, c1 upon c2. So you will get 1 upon -2, -2 upon 4 and 3 by -6. Here we can cancel, so it will be 2, 1 is 2, 2 to the 4, so it will be -1 upon 2. This is also -1 upon 2. This is also -1 upon 2, 3 1 is 3, 3 2 is 6. So we are observing the relation is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, because all three ratios are equal. So all three ratios here we are writing a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So from this we are observing the nature of the line is coincident line, one line is overlapping the other, and at this time we are saying it has infinitely many solutions. So point of intersection will be infinite many points. So we are saying it has infinitely many solutions. In the third case you have seen the lines were parallel, and in this case you will arrange the table. So you will write the value of a1 upon a2 and b1 upon b2 and c1 upon c2. So a1 upon a2 is 2 upon -4 and b1 upon b2 is -3 upon 6, c1 upon c2 is equal to 5 by 3. So here we are observing 2 by 4 is 1 by 2, so -1 by 2, 3 by 6 is also -1 by 2 and 5 by 3. So these two are, first two ratios are equal, but third is not equal. So we are getting a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. So this is the condition for no solution. And nature of the lines, they are parallel lines and we are observing they are not intersecting. So here no solutions and we are saying no point, nil point. So these are the observations after plotting these three graphs. So these we will arrange in the table. This is called observation. So for this you will make these tables with the help of scale and pencil. Please don't draw the rough diagram. All the lines you will draw with the help of scale and pencil, right? So this is observation. After this you will write about its conclusion, what result you get. So first point, the first system of equations represented by intersecting lines. So in the first case lines were intersecting, so that is representing intersecting lines, which shows that the system is consistent. Consistent means they have the solution. It has the unique solution, that is x is equal to -1 and y is equal to 2. This is the first solution, you can see from the first table. Then the second case, second system of equation represented by the constant line. Second case, there was a constant line, and which shows that the system is again consistent and it has infinitely many solutions. Third case was the third system of equation is represented by a parallel lines, and this shows that the system is inconsistent and has no solution, right? So you can see the third table. So this was the conclusion, and then the practical will be over. Now for this, to do more practice, you all are requested to do this work again. So for this, you can take these two equations for unique solution, and then you can find the solution like this, and you will plot the graph, and by this you can show the lines are intersecting at one point. So this is the next example for the same practical to do the practice, right? So this shows it is a case of unique solution, lines are intersecting at one point. So this is the second, I have taken the second example for intersecting lines. Now second example for parallel lines. These are the two equations. For both the equations, you will plot you will arrange the table for solutions, and after that you can plot them, and you will observe both the lines are parallel, right? Then you will say lines are parallel, so they have no solution and they are parallel lines, and system is inconsistent. Third case, this is the case of infinite many solutions or constant lines. So this is the example. These are the two equations. Arrange the table and plot the points. You will observe both the lines will overlap each other. So this shows that they have infinitely many solutions. They are constant lines, and in this way you can draw this. So here I have given two examples. One was given before this for unique solution, for no solution, for infinite many solution. This is also the case. So I have given two examples. So whichever you like, you can use that, and better you do both, right? So this will be a practice, and this will help you in linear equation chapter also when you will do the study about it. So this will help you in finding the solutions also, and this will help you in learning the tables, learning the conditions which will help you in solving the problems of linear equation chapter. So I hope you understood and you will do it. So this is all for today's class. Thank you very much, and please don't forget to mark your attendance in YouTube comment section, and write these practicals in your practical file. If you are not having practical file, do it in register, and arrange 3 graphs, and even on one graph you can divide into 3 graphs if you are not able to arrange 3 graphs. And whenever you are facing difficulty, please tell me directly. Don't pass this message to your class teacher and then it is coming to me that I am going fast. So whenever you are facing difficulty, please write the message to me directly so that I can help you in future. So thank you. Bye bye. Take care. Don't go out. Smile please. Right. Thank you. Bye.